Welcome to class. We're going to be going over Unit 6, Lesson 3 in our notes. If you're tuning in and you're not in class, you can look in the link for the description. But if you're in my class, you should have a handout for our notes, and it's going to be going over pages 9 through 11. And there's also going to be a template going over the four-step plan, which if you have it in class, it should be a pink handout. We're going to be looking at that first page on there. Our lesson is going to be revolving around how to use the four-step plan to write a confidence interval for a proportion, and that name of the proportion is the one sample z interval for P. And we're also going to learn how to determine sample size when we're trying to fit within a margin of error. It's going to be helpful if you have the formula sheet. If you're in the class, you can get a copy of the 3-page formula sheet there. If you're not, you can go to bit.ly/APstats formulas, and that'll take you to a PDF version of it, which you can reference if you need to. This is the formula sheet you get on all exams, so you might as well get comfortable using it. So let's take a look at first what the four-step plan is. And it's going to be revolving around basically 4 different sections. The first section is state. The second section is plan, do, and conclude. And when we do our work here, if you're asked to like calculate a confidence interval, right? The do part is the actual calculation. So that's like 1/4 of what we actually have to do to get full credit on a free response. So we have to talk about what we're going to be doing. We got to plan it out, see if we meet the conditions, and then we got to write our conclusion. So there's a lot more to it than just crunching the numbers. So if you look at the handout, y'all should have a pink handout if you're in class. Here's a template. The very front page is going over a one sample z interval for P. And that template is going to be basically the following. Okay, the first part is just stating, what do we want to know? All right, we're going to estimate the true parameter. So we have to list that parameter. Okay, in this case, it's going to be the true proportion of whatever we're working with in confidence. And you're going to state that confidence level. A lot of times it's 95%. You can calculate your sample proportion if you have it here. If not, you can do it at a later time. So that space can be done there. Then we want to plan it out. Remember, we have to meet 3 conditions. We have to meet our random condition. We want to make sure that our population is being sampled from randomly. We have to state that. So a lot of times in the problem, it'll specifically state that. We have to meet the 10% condition. That's also known as the independent condition, where we're not sampling more than 10% of our population. So the sample size, little n, should be less than 1/10 of the population size. It might not outright say that, but it should be assumed in most cases. And then the last part is we want to make sure our large counts are at least 10. So that means your n times since we don't have our population proportion, our n times our sample proportion, and our n times the complement of that, 1 minus the sample proportion, should be at least 10. So that large count allows us to be able to use a normal distribution. The independent allows us to use the standard error formula. Finally, the do part is when we're going to actually use the formula and calculate the confidence interval. We'll use our calculator's our stat test menu to help us verify that our answer is correct, but we do need to show work on that. And finally, our conclusion is we are this % confident that the interval from this to this number captures the true proportion of our parameter in context. So that's the template we're going to be using for all of our inference procedures, and throughout this unit, we'll be using this template: state, plan, do, conclude. So we want to get used to that now. If you want to look on the back side, there is an example of it. I will walk you through it real quick. Suppose we're interested in finding out the proportion of population independents that has seen The Office. Okay, we contact a simple random sample of 110 students in the school. Of these 110 students, 63 report seeing The Office. Construct and interpret a 95% confidence interval for the true proportion of independent students who have seen The Office. So what we want to do on this problem is we're trying to estimate the true proportion of independent students that have seen the show The Office. Now, only 63 of the 110 students have reported that they've seen The Office. So we know that if we divide those out, it's 110, so 63 out of 110. We're looking at about 57.3% of the students in our sample that have seen The Office. Now, is that the true proportion of all students at Independence High School? Well, we're not quite so sure. And that's why we build an interval around that to make sure that we can account for some error, okay? So what we're gonna write in the state part is we will estimate the true proportion of independent students who have seen the office at 95% confidence. We can go ahead and calculate that sample proportion. So we just show that division, and 0.573 is good enough as a rounding. Then we're gonna plan it out, okay? Are we gonna meet those three conditions? Has the sample been done randomly? Well, if you look on the sheet here, it specifically states an SRS, which is a simple random sample. So we've met that condition. We have to write that out. A simple random sample of 110 independent students was taken. Have we met the independent condition? Well, if you don't go to Independence, you might not know how many people there are, but there are over, it's reasonable to assume that if you times 110 by 10, you're going to get 1,100. And I think our school has about 2,000 people in it, give or take a few. So that has met, that condition has been met. So we can say that less than 10% of the population has been sampled, which allows us to use, remember, this standard deviation, well, the standard error formula. So that's really the reason why we do it. And then finally, our large counts, we want to make sure our number of successes and failures are at least 10. We have the raw numbers here. 63 said they saw the office. So we know that if we multiply 110 by 0.573, we're going to get back to 63. And if we multiply 110 by the complement of that, we're going to get 47, which is just 110 minus 63. And those are both greater than or equal to 10. So we've met that large counts condition, which allows us to do the normal curve. And now we can actually calculate our interval from that. So we do have to check these three conditions to be able to do that. That's that plan part. Sometimes in free responses, these are grouped together, like as far as the points are concerned. So you want to state the interval and check your conditions. State the kind of interval what you're trying to estimate and check your conditions. But always, just for good practice, just write that out separately. Our do part is when we want to construct the interval. So remember that our sample proportion is your point estimate. Our margin of error is your critical value times your standard error of the statistic. On your statistics formula sheet, you're going to find that generic confidence interval, right? Your statistic, which in this case here is p hat. Your critical value is, in this case, z star, and your standard error, well, that's not given to us. But if we don't remember what that is, you're going to go to this part of your formula sheet that has it. So if you go to the back side, you can see, well, standard error is that formula. So square root p hat 1 minus p hat over n. And so we don't have to memorize that, right? It's just right there. And so you're going to see that right there. Now, do you need to write down the formula to be able to get credit for the do? Not necessarily, because you can just input the numbers in there. As long as you state the type of interval we're looking at, it's a 1 sample z interval for p. If you write that down in there, then you've already covered what that is. So you can go right to the numbers if you want. If you don't name the interval, then you're going to need to write the formula. So it's kind of, which one would you rather write? If you're erring on the side of caution, you write them both. Well, we have our sample proportion. That's 0.573. Now, where does 1.96 come from again? Well, you don't have to show how to calculate that, but you have to know how to find it. So remember that your z star is your critical value, right? And that's about how many standard deviations we want to go. You should probably know at this point that 95% is going to give you a z star of 1.96, right? Because it's just shy of 2. If you're using a calculator that has inverse norm on it, if you have the option to go center, you can put 0.95 and go right to the center. And that'll tell you how many standard deviations from the center it is. So you can see, yeah, I'm at 1.96 standard deviations above and below the mean. But if you don't have that, like, my personal calculator doesn't have that on. This is a school calculator. So if I did second var's inverse norm, I only have to the left because that's the default. So what I'm going to do is I'm going to put parentheses 1 plus 0.95 divided by 2. That allows me to average that number with 100%, and that'll give me, 2.5% on each side of the normal curve. We'll leave that at 0 and 1 because it's a z-score. And there's your 1.96. For practical purposes, if you have your formula sheet with you, and you all should have access to a copy of it, I also taught you how to go to table B and get this. So when you find on the formula sheet, you're going to go to the fifth page, right? The first two are the actual formulas. The second two are the table A with all the percents from a normal distribution. The third table, well, I haven't taught you what all this is yet. This is called the t-distribution table, and that's table B. And critical values are what we're trying to find anyway. So these are all a bunch of critical values. And, without knowing the context of, what this means, if you look at that last row, that infinity row, you're going to see the most common confidence levels. So 95% right here is 1.96. You might have some that are 99%, 2.576, some that are 90. But most of the common ones, I would say almost always, the confidence level you're going to be working with is going to be right here on that bottom row. So you can kind of just look at that. If you go to your AP Stats formula sheet, on the document here that you can just Google, it will be the fifth page here. So it'll be right down there, 1.96. And so when you put it all together, you're going to plug in your sample proportion, because remember, this is standard error. We don't have the population. 1 minus that, your sample size was 110, your critical value 1.96, and you're going to calculate this out, and that's going to give you about 0.092. Now let's double check that, because we want to make sure our numbers are right. So we're going to do 1.96 square root 0.573, parentheses 1 minus 0.573, close parentheses, divided by 110. You can do it all like that. It'll calculate it correctly from there. And you can see that is a margin of error of about 9.24%. Okay, so 9.2%. And that's your margin of error. So I just call that ME. And then from there, we subtract it and we add it to get our total interval. So 0.573 minus 0.092. And that's your 0.481, 0.573 plus 0.092. And there's your 0.665. Now, we're going to want to check that work. So you write your formula down. You do got to show work and get these values in here. What you always want to do, especially if you have the time, is you're going to go into stat. So y'all press the stat, do this so you can get some practice doing it. Go over to tests. And this one is down on choice A. This is a one prop Z. Your calculator calls it a one prop Z interval, one proportion Z interval. It's called a one sample Z interval for P, but your calculator speak is one prop Z interval. So if you write one sample Z interval for P, that's the best way to do it. But if you forget it, you could at least run one prop Z interval. Up at the top, the X is the number of successes. So how many people said they saw The Office? That's 63. That's your X value. 110 is going to be your sample size. So we just put that, basically your proportion is right there. And then you set your confidence level. So remember, the wider the confidence level, the higher the confidence level, the wider the interval is. Default is going to be 1.95. Here's what your calculator gives you. It doesn't give you all the information you need, but it does give you the decimal answers just to verify that you got this right. So you'll see the low end there and the high end and the sample proportion. And this number, 0.572, it is exactly halfway between these two. So if you wanted to calculate your margin of error and you worked kind of backwards, you could say 0.57, I'll say 0.573 and round that up. And I know that this is 0.665. So if I do a little subtraction, that right there is your margin of error. So you can work backwards and get your margin of error if you really needed to, or if you're doing like a multiple choice question or something like that. And so here are directions on to show that. So you get your interval, you write that down as a coordinate, and then you make your following conclusion. We always put your confidence level in there. So we are 95% confident that the interval from what we just calculated captures the true proportion. And here's your context, guys. So in this case here, what are we trying to estimate? The proportion of students at Independence High School who have seen The Office. So our interval is hopefully going to capture that, but we don't know for sure. So that's why we say we're 95% confident, because we could be 100% confident and say that the interval from 0 to 100% is going to capture the true proportion of students who have seen The Office, but that doesn't really give you any meaningful information. So that is the state plan do conclude portion of the video. I'll stop this video here so that way we can just focus on the note pages for the rest of the video. But now that you've seen the template, you know how it is. This is how we can expect going forward to write these free response questions for all of our inference procedures, intervals, and we'll later learn hypothesis testing. All right, keep this pink sheet handy for you guys if you're in my class, and we'll use it again for other intervals. You definitely can reference it for your assignment, but you won't be able to use it on quizzes and tests. So study from it and use it to kind of help you construct these things as you're learning them. Thanks for watching, guys.